All right, so another general property. So I want you to focus more on, instead of looking at the individual cells of each layer, general properties between and differences between each layer. So what we have here is another protein called keratin. And what is keratin? Well, it's a protein and it's also hydrophobic. And what it does is here we have one single polypeptide of keratin, and it forms these little wraps around each other and starts to form these longer cables. So these form these keratin filaments. And the cool thing is that, why do I make a big deal about hydrophobic? Because remember, hydrophobic means that a chemical does not like associating with water, so it's going to repel water. So keratin is found in your skin. And this is why when you drop a bead of water on your skin, it doesn't immediately get soaked up like a sponge. So your keratin, now I think I have to check the most recent OpenStax, but what I often hear is like, this makes your skin hydrophobic and makes it waterproof. Well, like to think of to say, well, what if you soak in the tub for a long time? Are you going to have none of that water soaking into your skin or your other tissues as well? No, you actually get some water creeping in there and into the cells. So it's not completely waterproof. I like this term water resistant. So keratin, even though itself is hydrophobic, it doesn't make your skin completely waterproof. It does make it more on the hydrophobic side, but I like that term water resistant versus waterproof to describe your skin. But things like your nails are made of keratin too. Now, if you soak your nails in water, does it stay the same texture and density? Well, you notice that maybe your nails get a little softer when you soak it in water. So even though your nails won't dissolve like sugar in water, that would be really freaky if it did, it's still more waterproof. It's not, you can leave a nail in water, it's not going to dissolve like salt or sugars. So again, keratin is hydrophobic, but doesn't make the integument and its accessories completely waterproof like we associated with other waterproof surfaces like a tent tarp or something. So where you also find keratin? Your hair, right? So another example of why it's not exactly completely waterproof when you have these integument and structures. You can soak your hair, and I mean, I don't have hair right now, but when I had hair, you can tell when your hair is wet and your hair is dry, and there's different pliability and properties, right? So if you soak your hair, maybe it's easier to style, and when it's dry, it's harder to do that. So your hair does repel water, but it does absorb some. So again, keratin is important. It's hydrophobic, but it's not completely waterproof. I mean, it doesn't make a structure completely waterproof. Oh, another example, if you like animals, keratin, like horns. So the same thing. That's why it's like the horns of an antler of a moose or deer. That's the same thing. Or even like there are horns on rhino horns. I mean, it's so stupid that I'm sorry if that's part of your traditional medicine, but it's freaking keratin. And it's like they're killing these poor rhinos for their horns, which are just keratin. I was like, why not get keratin? Why not just grind up fingernails instead of killing these endangered animals? But oh yeah, sorry, a little rant there. But yeah, that's yeah, keratin is pretty much your nails and hooves and whatnot. So it's just a protein. But yeah, poor rhinos. Okay, so what we have here is the basal, and this is generating all the other layers. And what happens as you generate all these new layers is that you start to form these keratin granules. So you have these little pocket bunches of keratin, but what happens as these layers get pushed out is that these granules get bigger and bigger and bigger. And eventually, as they go toward the 5 layers or 4 layers in thin skin, then it goes to the corneum, and this is why the outermost layer of your skin is water resistant, and why you can put a bead of water on your skin and then wipe it off and have it roll off. So what happens at this point, it starts to form these long filaments, and this is why the outer layer of your skin is mostly hydrophobic. The cool thing is also, just like those, I mean, it's not going to be strong as like an antler or horn, but this does provide some mechanical protection as well. So it might not be completely as solid as your nails, but it is a layer compared to your typical squishy soft cells that on the inner side of your skin. These cells of your stratum corneum are going to be a lot more durable, and this is why it's kind of like your own like scales or plate of armor. And hey, what type of shape is this? Remember, this is an epithelium, And when we look at an epithelial cell shape, well, we know it's definitely stratified, right? Because that has multiple layers, it has multiple strata. But when we look at an epithelium, we look at the outermost layer, right? So when we look at this, the outermost layer, the most superficial, it's that flat, scaly, squamous flat cells. So this is why the epithelium, the epidermis, is a stratified squamous epithelium. And this process over here we saw here is keratinization. Now, do you need to know exact amounts of keratinization? Just know that as you push from deep to superficial, your cells start to gather more and more keratin. But the trade-off is that when you have this hydrophobic protein building up in these cells, the cells actually start dying as well. So they lose their nuclei as they transition from here to here. But at this point, they're so full of keratin, they're non-functioning, they're dead. So this is why when you shed these, or if you use one of those scrubby towels, like those Korean or Japanese scrubby towels, this is why you might feel something, but it's not going to be like, oh my god, I'm like when you get road rash, like you're skateboarding and you eat it and you tear off all that skin. Yeah, that's why if you just exfoliate, it doesn't hurt because those cells are already dead. There's no nerve endings there either.